Topic 5 is a continuation of topic 4, except we're just going to be working with a little bit more difficult of polynomials. So let's start off with example 1, where we have to expand and simplify the following. Now remember, the word expand just means to multiply these two binomials together, and then simplify is to combine like terms. So whenever we're expanding two binomials that are multiplying, we are going to FOIL it. Now remember, FOIL stands for first, as in the first terms, then the outside terms, inside terms, and then the last terms. So let's start off with the first term. So I'm going to put a little equal sign here. The first terms would be 3d times 4d. So that would be 12d squared. So that's the f in FOIL. Then let's do the outside terms. We got 3d times 2. So that would be plus 6d. Next we have the inside terms. That would be 4 times 4d, which would be plus 16d. And finally, we have the last terms, 4 times 2, which is equal to plus 8. So now let's simplify this a little bit here. We can combine like terms with these two in the middle. So then we're going to have 12d squared plus 6d plus 16d gives us 22d, and finally that plus 8 at the end. So that is our final answer. Moving on to example 2, let's do the same thing once again. So let's start with the first terms in each set of brackets. So we're going to have negative 2g times 7. So negative 2g times 7 would give us negative 14g. Then let's do the outside terms. We have negative 2g times negative 3g. So that would give us positive 6g squared. Next, let's do the inside terms. 8 times 7, that gives us 56. And finally, the last terms. 8 times negative 3g, that would give us negative 24g. And now let's combine like terms. So if you notice here, we got this and this that are like terms. So negative 14g minus another 24g, that would leave us with negative 38g. Then we have plus 6g squared and then plus 56. Now we actually have one more step in this one here, because following math grammar, we need to put this in descending order. So remember, we're going to put the biggest exponent first, then followed by the one below it, and so on until we reach that constant. So the biggest exponent here is that g squared. So we're going to put 6g squared. Then we're going to write the g term, so minus 38g. And then finally that constant at the end, plus 56. So this here is our final answer in descending order. Now let's take a look at some factoring again. So these questions, we're going to use our crisscross method for that we learned in topic 4, except they're going to be a little more difficult because there's just going to be more combinations of numbers that we could potentially use. We're also going to be adding one more step, and we're going to have to include what we did in topic 3 in order to do that. So on the top here, I'm just going to write what we have to do. Whenever we are given a trinomial like this to factor, we always want to check. So always check if a greatest common factor can be factored out. So before we even start using the crisscross method, you need to see if we could do anything like we did in topic 3, where we look at each term and think, can we factor a number out of each term? Can we factor a variable out of each term? And then our second rule to follow when factoring trinomials, and we talked about this in the previous topic, is the squared variable always has to be positive. And we fixed this last time by factoring out a negative sign. And remember, when we do that, it flips all the signs inside the bracket next to it. So let's look at example 3. Factor the following. Negative 4t squared minus 16t plus 128. So our first step is to check if a greatest common factor can be factored out. So let's look at all these numbers here. We got 4, we got 16, and we got 128. So there actually is a GCF that can be factored out. It is 4, because 4 divides into each of those numbers. So we could factor out 4. So if we factored out a 4, inside the brackets, we'd be left with negative t squared minus 4t plus 32. Because remember, if we were to distribute this 4 back into the brackets and multiply it to each term, it has to equal our original expression up here. Okay, so we completed this first rule here. Let's look at the second one. The squared variable has to be positive. Well, let's look here. Is the squared variable positive? No, it isn't. It has a negative sign out front of it, so we need to factor out a negative. So I just wrote here that we want t squared to be positive, so let's factor out the negative. So this is going to equal, we're going to factor out the negative, so now we're going to have negative 4 factored out. And inside the bracket, all of the signs are going to flip. They're going to change. So we're going to have positive t squared, then plus 4t minus 32. And now we are ready to crisscross factor. Now I do want to point out that once you get more used to this, you can actually just factor out the negative 4 from the get-go. You could look here and say, oh, I see that this term is negative, and I also see that 4 divides into every single one of these coefficients here and the constant. So I could just factor out negative 4 all in one step instead of doing it in these 2 steps that we did here. So now, following the crisscross method, we look at the 2 factors of t. Well, the only way we could split that up is t times t. And 32, we could either do 1 times 32, 2 times 16, or another one could be 8 times 4. And that's the one that actually works in this case, so I'm going to use that. So then we're going to have t times 8, which is 8t. And we're going to do t times 4, which is 4t. So now we need to get this middle term here. So if we have plus 8 minus 4, that does give us plus 4t, which is our middle term. Therefore, we're gonna put this plus sign up here and the negative sign down here. So our fully factored trinomial would give us t plus 8 times t minus 4, because those are our 2 things we have here in our crisscross. And then don't forget about this negative 4 that we factored out at the very start. So here is our final answer. So let's try some more of these. Example 4, we need to factor the following and check by expansion. So remember, expansion means to FOIL it. So let's follow the 2 rules that we wrote down on the top of this page here. Let's check if a GCF can be factored out. Well, we have 4, 21, and 5. I can't think of any number that divides into those. There's also no variables that we could factor out because there's no x in this term. So there's no GCF that we can factor out. So then our next thing, we need to check if this term is positive. It is, so we're good to go. We can just hop right into the crisscross method. So now you'll notice we have a coefficient connected to that x squared. So we can break this up a couple ways. We can either do 2x times 2x, or we could do 4x times x. Now the one that works for this one is 4x times x. That gives us 4x squared. And then the 5 over here, there's actually only one method we can do that, is 1 times 5. So now we're going to do x times 1 gives us 1x, or just an x. And then 4x times 5 gives us 20x. And we need to get 21x in the middle there, positive. So we're going to add both of these together. Plus x plus 20x gives us plus 21x. Therefore, a plus sign goes on the top here, and a plus sign goes on the bottom here. And our 2 factors are 4x plus 1 times x plus 5. And now I'm going to check this answer by foiling it. So check. And when we FOIL this, we should get the original trinomial that we started with. So I'm going to do 4x plus 1 times x plus 5. So let's start with the first terms. 4x times x, that would give us 4x squared. And the outside, we got 4x times 5, that would be plus 20x. Then the inside, we would have 1 times x, which is just plus 1x, or x. And the last terms would be 1 times 5, which is just plus 5. And if we combine like terms, we get the original expression that we started with. So we confirmed or we verified that our answer is correct. Let's try the next one over here. So starting off, we need to do our two rules. We need to check those two things. Let's first start with the GCF. Is there any GCF that we could pull out of here? Let's look at the coefficients. We have 6, 21, and 9. Well, 3 does factor into all of those. So we can factor out a 3. So I'm going to put an equal sign here, and I'm going to put a 3 out front. And then we think 3 times what gives us 6x squared? Well, that would be 2x squared. And then 3 times what would give us 21? That would be 7. And then the x there as well. And then 3 times what gives us 9? Well, that would be another positive 3. And then our second check is to see if that first term, that x squared term, is positive, and it is. So we are good to go here. So let's do our crisscross. So 2x squared, the only way to split that up would be x times 2x. And then the 3, the only way to split that up is 3 times 1. So then we're going to crisscross. So we have 2x times 3, that gives us 6x, and x times 1, that gives us 1x, or just x. So we need to get -7 from this, so I'm going to subtract both of these, because that would be -6 minus another 1 gives us -7x. So then we know that a negative sign goes on the top here, and a negative sign goes on the bottom here. So our final answer is going to be x minus 3 times 2x minus 1, and don't forget about that 3 out front. So our final answer is actually 3 times x minus 3 times 2x minus 1. And let's quickly check this one by foiling it. So when we foil this one here, because we have a number out front, let's just focus on the foiling part first. So let's do this part first. So what I'm going to do is I'm going to write the 3 out front, because we're not going to touch that. And everything I foil, I'm going to put in brackets next to it. So our first terms are going to be x times 2x, which is 2x squared. Then our outside would be -1x. Our inside would be -6x. And our last would be +3. And I'm going to close that bracket. And now that 3 has to be distributed to every single term inside the bracket. But actually, before we do that, let's clean up the inside of the brackets a bit, because we can combine like terms in there. So I'm still going to write that 3 out front, and I'm going to have 2x squared minus 7x plus 3 inside the brackets. And now let's distribute that 3 to everything inside the bracket. So our final step here would give us, well, 3 times 2x squared would be 6x squared. 3 times -7x would be -21x, and 3 times +3 is +9, and that's exactly what we started out with up here, so we know that our factoring is correct. Now, I also want to remind you here that, remember, with factoring, it's really easy to make a mistake because it's a lot of trial and error before your brain kind of gets used to looking at these and factoring them. So if you get to this step over here and there's no way to add or subtract these to get the middle term, then you have to make some adjustments to your crisscross. You can either switch the numbers, but in this case, there's no other number combinations to get 3, and there's no other number combinations to get 2x squared. So another thing you could do is flip them. So instead of having the 3 up here and the 1 down there, you could have the 1 up here and the 3 down here, and then you could do your crisscross again and see if it works. So let's move on to example C here. So starting off with our two rules, is there a GCF that we could factor out, a greatest common factor, from 9, 12, and 4? No, there isn't. I can't think of a number that divides into all those, and we can't take out a variable because there's no x available to us in that last term. And finally, is this x squared term positive? Yes, it is. So we are good to go to factor this using the crisscross method. So with the 9x squared, we can either do x times 9x, or we could do 3x times 3x. So I'm going to do 3x times 3x. And for the 4, we can either do 1 times 4 or 2 times 2. I'm going to do 2 times 2. So let's crisscross this. 3x times 2 gives us 6x, and 3x times 2 again gives us 6x. And is there any way for us to get positive 12x from that? Yes, there is. Plus sign here, plus sign there. Add those together and we get plus 12x. So I know a plus sign goes up here and a plus sign goes down there. So having this fully factored out, we would have 3x plus 2 times 3x plus 2. And there's actually another way we could write this. Let's think about it. What's another way that we could write x times x? Well, we could write that as x squared. That's basically the same thing going on here. We have two things that are the exact same multiplying together. So we can write this as 3x plus 2 squared. And that's our final answer. And of course, we can check this by foiling. So I'm going to do that and skip ahead. So there we go. I just checked it and I got the same thing as our original trinomial. Moving on to this example D. First step is to see if a GCF can be factored out. So we have 4, 10, and 6. Well, all of those can divide by 2. So let's factor out a 2. So 2 over here. And 2 times what gives us 4? That would be 2. And then we have that x squared there. Then 2 times what is 10? That'd be 5x. And finally, we have 2 times 3 would give us that last term, 6. And our x squared term is positive, so we don't have to factor out a negative. So now let's crisscross this here. 2x squared, well, we can only do x times 2x. That would give us 2x squared. And for the 3, we can only do 1 times 3. So then we have 2x times 1, which is 2x, and we have x times 3, which is 3x, and I need negative 5 in the middle there. So I'm going to do minus 2x minus 3x, and that gives us our negative 5 term in the middle. So I know that a negative sign has to go up here, and a negative sign has to go down here. So our fully factored answer is going to be, I'm going to write that 2 out front, and then we're going to have x minus 1 times 2x minus 3. Now this one here is actually a trickier one, and we looked at one of these in class as well. Let's say we factored this as x and 2x, and then we did the 3 up here and the 1 down here. So instead of doing it 1 and 3 like that, I did 3 and 1. Now this is going to look like it works, but if we were to check our answer, we wouldn't get the exact thing as we started with. So let me show you. So 2x times 3, that would give us 6x, and x times 1 gives us 1x. And I could say, okay, I need negative 5x. Cool, I could do negative 6 plus 1. That gives me negative 5x. So a negative sign goes here and a plus sign goes here. So this is one extra step that you want to take to check your answer. So the one more step we have to check is this here and this here. And we have to think, does negative 3 times positive 1 give us positive 3? Because if we were to FOIL that out, x minus 3 times 2x plus 1, we would eventually have to multiply the two last terms, right? If we're FOILing. And negative 3 times positive 1 gives me negative 3. That doesn't equal what we are factoring up here. So this is a tricky one, and you need to take that extra step to see if you get that constant term with the correct sign. There aren't a lot of questions like this, but there are a few. So try to get into the habit to think when you get these two signs here, okay, will a negative times a positive give me a positive? No, it doesn't. If we look at the answer we actually get, well, a negative times a negative gives me a positive, so I know for sure it's going to work. If we look at the previous example, a positive times a positive gives us a positive, so I know it works. Let's look at the ones up here. Does a negative times a negative give us a positive? It does. So try getting into the habit at the very end to check those two signs and see if you get this second sign connected to that constant term. So now I went back to the D example here and I checked my answer and I do get the original equation there. So we know we're all good.